Oh. Okay. All right, here we go. We're going to talk about three things. I don't know if we'll get to all three of them today. We'll see how it goes. All right, distances, midpoints, and slopes. Before we talk about the distance, midpoints, and slopes, we're going to talk about some other things just to lay some foundation before we actually get to this. All right, first little phrase, it's called an ordered pair. Do you remember what an ordered pair is from Algebra 1? You got parentheses, you got a comma. What goes in the first spot? X and then a Y. Very good. So that's called an ordered pair. It's in a certain order. The X always goes first, the Y always goes second. All right? And it represents a point on a plane. All right? So this right here represents a point. Point has two parts to it. It's got an X part to it, and it's got a Y part to it. All right, that's good enough. Let's do this. You probably did this stuff in Algebra 1, didn't you? Oh, yes. You got two intersecting lines. One is horizontal, one is vertical. And since this is an X and a Y, we call this an axis. A-X-I-S. Yeah, what is this one? This is the x-axis. The horizontal one is the x-axis, and the vertical one, the one that goes up and down, of course, would be the what? The y-axis. Very good. You got two of them. You got an x-axis and a y-axis, so that means you have two, what? What's the plural of axis? Axes. Very good. Okay, looks like axes, but it's axes. Okay, two axes. You got one axis, all right, that's singular, and you got two axes, just so you know what the words are. These two axes intersect each other. They intersect each other, they're perpendicular, so that's a right angle right there, all right? But it's broken up into four different areas. You got this thing, it's called a quadrant. Very good. Let's write that word down. All right, this top right one we call the first quadrant. For whatever reason, they usually put it in Roman numerals. All right, so that's the first quadrant. This is the second, the third, and the fourth. All right, it's pretty nice when I talk about a point being in the second quadrant, you know exactly where that is. All right, we have a point right in the middle. This is where they intersect, the intersection of those two axes, and it has a special name, and it's the beginning. All right, it's called the origin. Very good, because that's what the word origin means. It means the beginning. All right, so that's where we start, right there at that intersection point. Okay, that's called the origin. And let's talk about it. It has, oh, by the way, this word right here, or not word, but this whole thing is also considered to be a coordinate. All right, it's a coordinate. It's a point, right? It's the location of a point. That's what the coordinate is. It's the location of where a point is. So where is the location of the origin? Well, it's right here. So this is where we start. And so how far do we have to go to get to there? We go 0. All right, so you go 0 on the x-axis. How far up and down the y-axis do we have to go to get to that point? 0. So the coordinate of the origin, we got a lot of words, right? A lot of different words to learn. The coordinate of the origin is at 0, 0. All right, so when I ask you what the coordinate is, that means it's the location, where it's located, and it's right there, 0, 0. People use maps, well, they used to use maps all the time until GPS came around, and we just look at it and it talks to you and tells you where to turn and everything else. But it used to be, we had these big old maps. They unfolded like this, and like maps would, sometimes they would have like a B, C, D, E, F, G down the bottom, and have a 1, 2, 3, 4, 5, 6, 7 across the top. And then if you're looking up somewhere, if you're looking up a place to go, sometimes it'll say go to G4. What does that mean? You go down this way to G, you go across this way to 4, or whatever it is. It could be across as the G and down as the 4. I don't know. All right, and then you go this way, and boom, there you are. That's the coordinates of where you are on the map. Okay, if you on your GPS, you could, I think you hold it down. I don't know. You do something, you double click on it or something like that, and it'll give you like the latitude and longitude numbers. Those are coordinates of where you're located, the exact spot on Earth where you're located, and you can find those things. All right, it's kind of interesting, but people use coordinates all the time. So this is not something that we're just going to learn as just goes away. I mean, people use this all the time to figure out, like you ever watch these news clips where we fire a missile and it hits, like, have you seen recently, there's these boats, they're out in the ocean, right? And who was it? What country were these guys from? They're Somalia or something like that? Maybe, I forget. Anyway, some country that didn't want to do very good things. They had all these drugs. They had tons and tons of drugs on their little boats, and they're going through the ocean. And you know what we did? We flew over, hit a missile, and boom, just knocked them right out of the water, right? I laugh because they're trying to kill Americans is what they're trying to do, you know? And so they have to have a coordinate system. They got to know exactly where they are. And probably the person that fired the rocket probably didn't even see them, right? They knew exactly where the coordinates was because of satellites and all that kind of stuff. And they just lock it all in, push a button, the missile comes, boom, knocks them out. It's crazy. So coordinates are very important. All right, this whole thing right here with the X and Y axis, that also has a name, all right? You could call it a couple different things. You could call it a rectangular coordinate system. All right, sometimes people will call it that. Another name is named after a guy, named after a French guy. The guy's name sounds like a girl's name, but in France, it's a guy's name, I guess, too. It's Rene, and then Descartes. C-A-R-T-E-S. I'll squeeze it on here. Rene Descartes. It's got an S on there, but in France, I guess they don't pronounce the S. So it's Rene Descartes. He actually lived from 1596 to 1650. All right? So, long time ago. That was before the Revolutionary War. 1650. Wasn't even around in the 1700s. So it was a long time ago. All right? And he kind of came up with this system. At least they named it after him. He probably had a lot to do with it. He did a lot of things. He was a philosopher. He was a scientist. He was a mathematician. He did a bunch of stuff. And I got in my notes, it says he connected geometric figures to algebraic equations. So he took stuff that people knew and he kind of filled the gap in between algebra and geometry. All right, pretty important person in math. Look him up sometime. I don't know much more about him. I haven't done a whole lot of research on him. But anyway, they gave this his name and they call it this, the Cartesian plane. Sometimes they'll call it the Cartesian coordinate system again instead of rectangular, but Cartesian, do you see where his name is in there? It's the cart, not the day part of it, but at least the cart, C-A-R-T-E-S.
Wait, what is this for?
This whole thing with the quadrants and the axes and all that kind of stuff, that's called, well, it is a graph. It is a graph, but it's named after this guy, the Cartesian coordinate system, or the Cartesian plane is what we call this. When you have an X and Y axis, you got the quadrants, you got the points, all that good stuff, and you put the coordinates in there. That's sometimes what they call it. All right, enough of that. Let's put some points in here. Let's do this first. If I start at the origin, I go to the right, what sign will I use if I go to the right? I'll use a positive. So this would be the positive x direction, and this would be the what? Negative x direction. If you go up, what would you call that one? Positive y direction. If you go down, that would be what? The negative y direction. Everybody good? So we got it all set up. Now what we want to do is we're going to put some points in here. So these are number lines. Bless you. These are number lines. I'll just go real easy. Just go to 3. 1, 2, 3. There you go. So if you go to the right, I got too much white in here. Let's add a splash of color. Watch. If you go to the right, this would be positive 1, positive 2, positive 3. If you go to the left on the x coordinate, I got that 0, 0 there, but I'll put in the negative 1, negative 2, negative 3. All right, if you're going up, again, it's positive, so that's 1, 2, 3 in the y direction. And then down would be negative 1, negative 2, negative 3. You've seen this stuff before, haven't you? Yeah. So I'm going through it fairly quickly. So if I put a point on here, let's say I put a point right there, and I ask you to find, we'll call it point A, and I say, what is the coordinate of point A? You're trying to find the location of that point. How would I describe to somebody where that point is? Do I say, well, you go over a little bit this way and go over a little bit this? No, what would you do? You'd say, you go 2, what? 1, right. It's 2 and then comma 1, just like you said. All right, so that's the coordinate of point A, the location of where that point is located. Make sense? Yeah. What if I asked you to put, let's say I gave you a coordinate and I asked you to graph it, okay? So I'll ask you to graph like the coordinate of point B, and we'll call it negative 3, negative 2. All right? So if I ask you to graph it, you draw the little x and y axis thing. All right, here's the origin, and where do you go? Where do you go first? To negative 3. So you go 1, 2, 3 right here. You don't put a point just yet. Then what do you got to do? Go down 2. 1, 2. So that would be about right here, wouldn't you agree? About right there. And there it is. That's point B. And that would be at negative 3, negative 2. This is stuff we're going to be doing a lot of times. We're going to be doing this stuff, especially in algebra, pre-calc, calculus, all that kind of stuff. It's all based on the Cartesian coordinate system. Everybody good? All right, enough of that. That was just a warm-up. Uh-oh. It was just learning the words, okay, and all that good stuff. What I'm going to do, let's do this. I actually have a nice little coordinate thing already made up. Put it over here on the side so I can just copy it. I don't have to redraw it every single time. It's a little small, so let's make it a little bit bigger so I can see it. All right. And that's a graph. Somebody said, I thought it was just a graph. Well, it is. It's a graph with all the lines. Each one of those lines represent, well, it could represent whatever you tell it to represent, but normally each one of those lines represents 1. All right. There's the origin. So if I asked you, just real quick, if I said, what is that point right there? Point X. X marks the spot. It'd be 1, 2, 3, 4, and then 1, 2, 3, 4, 5. So you would say it's at 4, 5. Everybody got that? Okay. Enough of that. Let's get into the first thing we're going to talk about. What was the first thing of this lesson? What did it say? Distance. So let's talk about distance. We've actually talked about that a little bit earlier in the year. Remember we said, I'm just going to do just going over in one direction, just in the x direction. So what if this was at, I don't know, let's make it super easy. That's 2 and that's 7. What is the distance between 2 and 7? Or sometimes we call that point A and point B. And then I said, do you remember this? If I just said find AB with no line segment over top of it, that's it. If I just said find AB, what does that mean when it says AB with nothing over top of it? Find the length of it, right? Or the distance, right? That's what we're doing now. We're finding the distance or the length from 2 to 7, from point A to point B, right? Do you remember the math that we did to do that? You could count, right? To what? 3, 4, 5, 6, 7. You could do that, but that'd be silly, wouldn't it? All right, because if I was at negative 284 and I wanted to go up to positive 731, I don't want to sit there and count on my fingers how many places it is, right? So what am I going to do? What's the math involved? Just subtract. That's right. Just subtract. Doesn't matter what order you subtract them in. No, because you're always going to take the what? the absolute value, right? Which just means what? Everybody gets all crazy when you hear absolute value. They're like, oh, that's so hard. It just means you take the positive version of that answer. So you could go 7 minus 2, which is 5, or you could go what? 2 minus 7. Well, 2 minus 7 is negative 5, but if you make it absolute value, what do you get? You get positive 5. So the distance, we're not talking negatives. We're just saying they're all positive, okay? So the distances are all going to be positive. So that was review. That shouldn't be new to you, should it? So how do you find the distance? Subtract. Yeah? All right. Now here's the deal. What if you had a point right here and a point right there? We'll call that A and B again. It's really not that bad. Watch, I'm going to connect them. Basically the same thing, isn't it? All right, but I'm going to, on the next thing that we do, I'm going to switch it up a little bit, okay, make it a little bit tougher. So let's find the coordinate of this point A. What is the coordinate of that point A? Well, what do I got to do? I got to go on the x direction first, then the y, correct? So I go 1, 2, 3, 4, 1, 2. So what is the coordinate of point A? It's negative 4, 2, right? What's the coordinate of point B? Not 1, negative 2. 1, 2, right. You go to the right 1, to the right is positive, and you go up. Up is positive, so it's 1, 2. Everybody good with that? How do I find the distance between those 2 points? Subtract what? What about the 2's? Well, the 2's don't even, you don't have to worry about the 2's in this situation, all right, because I'm just finding the horizontal distance. Do I really care? Look, would the distance be any different if I was up here like this? No. So really, does the y make any difference here? No, because it's horizontal. So all I got to do is subtract which values? The x values, okay? So here's what I'm going to show you. I'm going to show you something. It's kind of a weird looking thing. I'm going to say, that looks like a triangle, okay? But it's a Greek letter of the alphabet. Yes. Yes. Just on the ones that you did? Just take it again.
Sounds good to me. I could do it right now.
No, I'm in the middle of teaching. What's that thing mean? The change in. Change in. What's that Greek letter? Oh, come on. Oh, you know it. Oh, man, see, I was giving you a chance to shine in front of everybody. It's a delta. You don't remember that? Oh. Oh, yes, you do. All right, so anyway, this is a Greek letter of the alphabet. Looks like a triangle, but we call it a delta. Okay, it's actually a letter in the alphabet. I guess it kind of corresponds to our letter D. I don't know. I don't know much about the Greek alphabet, just know a few of the names of the letters, but that's a delta. It means the change in something. The change in. So this is considered the what? The change in x. So that means if I go from here to here, I'm changing from this point to this point. Everybody see that? That's the change in x. There's a reason I'm saying this, because what we're going to do in a few minutes, okay? This is the change in x. So how do I find the change in x? Well, I take one of the x values and I subtract the other x value from it, just like we did that distance stuff. All right? I know I probably am making it sound more confusing than it is because I introduced that delta thing. You're like, what? Greek letters? You know, but you've dealt with a Greek letter before. What's a real famous Greek letter that you've dealt with in the past? Sigma? You've dealt with sigma in the past? I don't think so. Not at this level. You will. That is a mathematical thing, okay? They got a whole entire class that's basically deals with sigma, with statistics. What is that? Somebody said it. Nah, have you dealt with alpha in math? When have you used alpha? I mean, you're just saying letters that you know are Greek letters. What's a Greek letter of the alphabet that you've dealt with before? What about a circle? What do you use in circles? What? Circumference. Okay.
Radius?
Pi. There you go. Pi. Pi is a Greek letter of the alphabet. I thought you would get that so much faster. All right, anyway. But that doesn't bother you, right? Pi, it's the same thing. Delta x is the change in something. All right, so that's what it means, the change in x. And again, it doesn't matter what order you subtract them in. It doesn't make any difference as long as what? The answer is positive. You got it? Okay, so let's I don't know if I should have said that exactly. I don't think I said that exactly right, but that's good enough. Let's do that. Let's take the x's, right? The x's and subtract them. It doesn't matter what order you subtract them in. You could go -4 minus what? What's the other x? 1, which is what? -5, but what's the distance? The distance is just 5, okay? Now this will be important in a little bit, but for right now, what is the distance between A and B? It's just 5. I could have sat there and counted, couldn't I? 1, 2, 3, 4, 5. I could have done that, but it's a lot easier just to subtract. I could have subtracted the other way. I could have taken that first x and subtract the other x from it, or the second x and the first x. What's that? What's 1 minus a negative? 1 plus, which is 5, and there you go. So the distance is 5. Everybody good? All right. I'm just setting the stage for what we're going to do about right now. All right, so just bear with me. Let's get rid of this stuff. Get rid of that. Okay, so now what we're going to do, here's what we really want to get at. Can you see that green okay? Yeah, that's not bad. Okay, so what we're going to do now is I want to find the distance diagonally. So if I found I did one horizontal, but you could also do it, I'll tell you what, let's do a vertical one. Carly, what are you hiding from me? Yeah. Because I looked up and then you like straighten up real quick like you're hiding some. Sure look like it. All right, what about this? What if I asked you to find the distance? We'll call this C and D. What if I asked you to find the distance between C and D? You could just count, all right, that'd be easy enough. But let's put some numbers in. Let's find the coordinate of this point right here, C. 1, 2, 3, 4, 5. 1, 2, 3, 4. So it's 5, 4. And this point right here, well, it's -5, I'm sorry. -5, 4. And this is -5 what? 1, 2, 3. So that's -5, -3. And if I wanted to find the change, now it's not in x this time, is it? It's the change in y because it goes up and down, all right? I promise, I'm getting somewhere with this, all right? It's not just these individually. So what is the change in y? It means you just subtract the y's from each other. Just subtract the y values. Because you went over the same on the x, the y is the only thing that's different. So I got a 4 and I got a -3. So 4 minus -3. What's 4 minus -3? It's 7, and that's the distance from here to here. I could have just counted 1, 2, 3, 4, 5, 6, 7. All right, I could have done that, but it's important, I think, for you to understand that. Now, what we're going to do is we're going to put those two things together. So now you know how to find the distance horizontally. Now you know how to find the distance vertically. Now what we're going to do is draw a diagonal. And again, like I said, you could have just counted. But when you draw a diagonal line, you're not going to be able to just count. Okay? It's pretty important that you see this. So let's do another one. What I'm going to do, yeah, I'll show you this. You're honors, right? What? You don't like that? Let's do this. Let's do this. I don't really care what numbers points they're on. I'm going to do this in general. Okay? I'll show you what I'm talking about. Because I don't know if this comes out real pretty or not. So what we're going to do is now we're going to find the distance of that yellow line. Can I just sit there and just count 1, 2, 3, 4, 5 like I did the other one? Well, it's not that. It's not. We're not doing the slope. Finding the distance between there. Can I just count 1, 2, 3, 4, 5? No, because I don't know. Like from here to here, is that exactly 1? No, not diagonally. It's not. Okay, so I can't just count. I got to have another way to figure out the distance between those 2 points. All right. So here's what I'm going to do. Now watch carefully. It's going to blow your mind for some of you, but write down what I'm writing down and try to listen, okay? I'll call this, I'll call this point A, and I'll call this point B. Let's pretend I don't really have the graph there. In fact, you know what? Boom, there we go. Don't have a graph there, all right? So I don't know exactly where that point is, but I'm going to call it x1, y1. Everybody see what I'm doing there? All right? Because I'm going to have a second x and a second y. So this is going to be my first x and y, then I'm going to have a second x and y. So this represents any point on the graph. We good? So it's not specific to just one point. So what do you think I'm going to call this point right here then? x2, y2. Very good. Okay? What I need to do is I need to find the distance from here to here. I'm going to draw another color here. So here's what I'm going to do. I'm going to draw a horizontal distance until I get right below B. And then, oops, let me get rid of that. And then I'm going to draw a vertical distance from here to here. I was off a little bit. Let me scooch it over. There we go. See what I did? So I made a triangle out of it. Not just any triangle, because I went horizontal and vertical. So what kind of angle do I have here? I have a right angle, don't I? Now, here's what's a little bit tricky. This is what always throws people off. But it's not that big of a deal. If you don't understand what I'm doing right here, it really doesn't make any difference. What I'm trying to do, okay, this is not something you're going to have to do on a homework necessarily, okay? What we're trying to do is come up with a formula to find the distance between A and B of any 2 points. You with me on that? Stop. William, move your desk up a little bit and get your foot off his desk and pay attention to what I'm saying. Are you writing down anything? You don't have anything open. Yeah, well, it was upside down, so it's kind of hard to write like that. All right. Do I have your attention now? Okay. You don't need to be a goofball all the time. All right. Now it's serious. So watch. What I'm trying to do is come up with a formula to find the distance between any 2 points. All right. That's what I'm trying to do. You're not going to have to do what I'm doing right now. You're not going to have to do that on a homework or a quiz or a test. Okay. Since you're honors, I think it's a good idea to see where these formulas come from. I could just put the formula up there and say, this is how it works, boom, find the distance. That wouldn't be any fun though. All right, I want you to see where this comes from, because it's going to look really weird, but I think it's important that you guys see where it comes from. Anyway, what is this point going to be right here? If look, here's the x's right here. So what's the x part of this going to be? It's not going to be a 3. It's going to be x2. That's right. Because why? It's right underneath of this x2. Do you see that? So we went over the same amount to get to point B as we did to get to this point. What's the y part of this going to be? It's going to be y1. Because look, this one is at y1. So you went down, right, y1 to get to here, like, right, from here to here. And then you went down the same thing here. If you don't understand that, it's not that big of a deal, but it's important for what we're going to do right here. So now what we're going to do is this. I'll tell you what, let's backtrack just a little bit. They didn't teach this to you yet, and it's kind of funny that they would do this now, because I thought for sure they would have taught you this. But you might have done this in Algebra 1. Do you remember Pythagorean theorem? Yeah.
The word, but not the theorem.
That's all right, but you heard the word before, right? Well, that's a good start. All right. I'll show you what it is. Pythagorean theorem says when you have a right triangle, and we're going to get back to this in a second, just got to do a little background here. If I call this length A, and I call this one B, and I call this one C, do you remember what the Pythagorean theorem said? I tell my students Pythagorean theorem is as easy as ABC. Does that help it at all? Does it? Thank you. A squared plus B squared equals C squared. Has anybody seen that before? Yeah, you've seen it before. You just didn't remember. But it should be something that just comes off the tip of your tongue. All right? A squared plus B squared equals C squared. All right? What does that mean? That means if I take the length of this side and square it, then I take the length of this side and square it and add it up, it's going to equal the length of the third side squared. All right? This third side right here is opposite the right angle. What do we call that third side? It starts with an H. Hypotenuse. Very good. So you have learned some of this stuff. And you should have. I mean, I kind of have a little bit of an expectation for you when you come in here. All right? So you've probably at least heard of this at some point. All right? That's the hypotenuse. These two are the what? We have talked about that. Those are the legs. Okay? Have we talked about hypotenuse in here earlier in the year? No? Okay. All right. So, with that said, what I want to try to do, I want to try to find the length of the blue, the length of the green, and then I'm going to apply the Pythagorean theorem to it, and then I'm going to have my distance. Okay? So, we'll try to stay color coordinated here. So, I'm trying to find the distance. I'll call it D. And so what I'm trying to do is to find this blue one. This blue one would be the change in x. Why? Because it's horizontal. Remember before we talked about the change in x? See where it's going now? What do you think I'm going to call the green one? The change in y. How did I find the change in x? Look in your notes. I wrote it down. How do you find the change in x? Subtract what? The x's from each other, right? So you could go, now a lot of books go x2 minus x1. I kind of understand why they do that. Is that all right if we do that? Because it doesn't matter, does it, what order you subtract them in? Remember, because you're always going to take the positive version anyway. All right, so let's go x2 minus x1. Most books do that. So what do you think the y is going to be? Good. y2 minus y1. All right, now we're getting somewhere. So this is the distance between this point and this point along the x-axis. It's x2 minus x1. This is the distance between this point and point B. That's the change in y, which is y2 minus y1. So now what we're going to do is we're going to apply the Pythagorean theorem to it. So it doesn't matter which one you call A or B. So let's just call the x the A, all right? So what are we going to do? We're going to go x squared. Let's do this in a different color. Let's go neutral. Let's go white. So watch. What I'm going to do is I'm using this now. I'm going a squared. What's the a in this situation? Well, it's x2 minus x1, okay? So watch what I'm going to do. I'm going to go x2 minus x1, and what do I have to do to it? What did I do to that a? Had to square it, didn't I? So I'm going to take that. Why did I put a square right here? That was dumb. x2 minus x1, sorry. And then I'm going to square it. You understand what I'm doing? That was a, and so I'm going to take that a and square it. Plus, what? B squared. What's the b? It's not squared. It's just y2 minus y1. So it's y2 minus y1. And what am I going to do with that? Now I'm going to square that. What's that equal to? In this case, right, I made the c in the Pythagorean theorem, I made it d. Why did I make it d? D for distance, right. So I'm going to put d, what? Squared. That basically right there is the distance formula. But I'm going to write it just a little different. I want the d by itself. I don't want d squared. So how in the world would I get rid of a square? Square root it. Very good. Okay, so I get rid of the square by square rooting it. So I square root that. Whoops. I square root that. And then what do I got to do? Square root all of it. Very good. So now we are ready. With all that said, we are ready to write the distance formula nice and neat and pretty. Okay? This is what you'll see in the book. So you'll see distance equals square root. And then I like to do this. I just made up this name. I call it the shell of the formula. It's kind of like the outside stuff, right? Like a crab, you know? And then all the stuff inside is just kind of the guts of the equation. All right, so what do I put in that first one? x2 minus x1. And what do I put in the second one? y2 minus y1. Now, it absolutely does not make any difference if you go x2 minus x1 or x1 minus x2. Doesn't make any difference. Because what are you going to do with that number anyway? You're going to take whatever that number is and then do what to it? I'm circling it. You're going to square it. Okay? What happens when you square a number, whether it's positive or negative? What's it always going to be? Double. So, no, it's not double. It's always going to be positive. Right. It's always going to be positive. Okay? So this number, no matter how you subtract, will always be positive. This number right here, no matter how you subtract, will always be positive because you're squaring it. Make sense? So this will be positive, you're adding it, so you'll always have a positive number inside the square root. If you happen to do the work and get a negative number inside the square root, you did something wrong. Right? And there it is, right there. That is your distance formula. How do you use it? Well, I'm glad you asked. We're going to do that. All that stuff that I did right there was just leading up to what I'm going to do right now, okay? You're not going to have to do that stuff on a quiz or a test. Don't freak yourself out over it. Don't worry yourself and say, oh, I'll never do that, all that stuff. This is what you got to understand, okay? This is what you have to understand. So here's what they're going to ask you on a quiz or a test. Flip my notes over a little bit. This is example 1. And they're going to say, find the distance. Find the distance between, and then they're going to give you 2 points. And here's the first one they do. They go -2, 5, and 4, 1. Okay? So here's what you have to do. Actually working this problem out is really not that hard. It's just plugging numbers into a formula and then just working it out. What you have to do is you have to memorize this thing right here. I will not give this to you. You must have it memorized. Okay? But here's what I would suggest. Every time you do a homework problem with this, I would write the formula down every single time. The more you write it down, the more you're going to remember it. Don't just put it up in a corner somewhere and refer to it. Don't put it on a piece of paper next to your homework and just refer to it. Write it down every single time you do one of the problems. You hear me? Okay. Can't stress that enough. Now, hardly any of my students, I shouldn't say hardly any, but not enough of my students do this, and it's to their detriment. All right. So, what's the first thing we're going to do? What did I just harp about? Write down the formula. Very good. You guys are catching on. A little slow, but you're catching on. All right. So here we go. What is the formula? What do we start with? What's that big old thing we put in there? Big old square root. What I like to do, I like to put the shell together first, all the outside stuff. So what does that mean? I'm going to put a parentheses here, put a plus, put another parentheses, and one more thing. Put a little squared here and a squared here. That's the first thing that I do. And then you can just fill it in. So what do I fill in that first part? Well, let's just write the formula down first before we worry about numbers. Yeah, x2 minus x1. And again, does it matter if I go 2 minus 1 or 1 minus 2? No. And then what do I put over here? Yeah, y2 minus y1. The only reason I put the 2 first, because most books do that. Whatever. Now I'm ready to actually solve this thing. Not solve it yet, but plug stuff in. So distance equals big old square root. See how many times, and when you have to do several of these problems, you're going to get so used to it, you're just going to write that down just like that. But you got to write it down like that, okay? You got to do it. You can't just try to remember it. Write it down. So now what am I going to do? I'm going to take my x's and subtract the x's from each other. So which ones are my x's? That's right, the -2 and the 4 and the -2. So that's my x1. This would be my x2. All right, so make sure you're only subtracting the x's from each other. Don't subtract an x and a y from each other. Okay, just subtract the x's. I'm going to write it down. You could go -2 minus 4, or you could go what? 4 minus -2. It doesn't make any difference. The only thing different is one's going to be positive, one's going to be negative. But when you square it, it doesn't make any difference, does it? Because if you square that negative, it becomes positive. You square the positive, it stays positive. All right. So anyway, let's do the y's. Now we got to subtract the y's from each other. So this is our y1 and this is our y2. So what am I going to do now? Yeah, 1 minus 5. Or you could go 5 minus 1. That's perfectly fine. You could do one way and one the other way. All right? It doesn't make any difference. Now, I think you've done the hardest part of this problem up to this point. I think the rest, it's a piece of cake. I think it's easy. So keep that square root. Don't forget that square root. And now let's do this in math. 4 minus -2. What's 4 minus -2? 6. And then what do we have to do to that 6? Square it. Some of you guys might be able to just do that in your head. Oh, that's 6. 6 squared is what? 36. That'd be okay. But I'm showing you every little step here. What about this? 1 minus 5. What's that?
4.
It's not 4. It's -4. But when you square a -4, you're going to get a positive 16. But I'm going to write it like that. Okay? Pretty easy, isn't it? Yep. 6 squared is 36. What's -4 squared? Positive 16. Very good. And you add those up. What's that? That's a 4, the 1, that's a 12. 52. Yep. And that is your answer. And you're like, well, that's a weird number. That's all right. Still a number. If you wanted to find a decimal equivalent, you could put it into a calculator, figure out what it is. But I'm good with this, okay? I don't see any reason, right now, I don't see any reason to do anything more with that. And that's all there is to it. It's pretty easy, isn't it? Yeah. But you got to know the formula. If you don't know the formula, you're sunk. You won't know what to do. You got to write it. You got to write it and write it and write it. Well, don't forget it. That's all I can say. You got to study it. Quiz each other. All right? You're sitting in lunch. Okay, what's the distance formula? Because there's going to be 2 other formulas we're going to learn. Okay, this is only 1/3 of this lesson was the distance formula. I don't need to take near as long to do the other 2 because we've already talked about the coordinate plane and all that kind of stuff. All right? But we're going to do kind of the same thing. What was the second thing this lesson was about? Midpoint. So we're going to have a formula for midpoint. And we're going to have a formula for slope. Very good. Okay? So there's going to be 3 formulas that you're going to have to learn from this. And you're going to have to know them. All right? I will not give you a cheat sheet. I won't put it on the test or anything like that. You're going to have to know the formula. But once you get used to it, it just becomes like that. But the thing is, write it down every single time. Every time you do a problem, write this down. You're kind of doing it twice, aren't you? Because you're doing this, and then you're doing it again, right, when you put the actual numbers in there. So by the time you do all those problems, and you're writing down the formula every single time, you're going to have it down pat. All right? And that's how you leave your answer, just like that. Easy. We good? All right. I have a whole lot more to do. So what I'm going to ask you to do, well, this will make it easy for you. I'm going to wait till we're finished this lesson before I officially assign the homework. And I don't know, let's see, I got my book right here. let's see. I'm just going to have you do the ones where it asks for the distance, but I have a feeling they might ask for like all three things on some of these problems. No, they don't. All right, so let's do 1 through 6. All right, you're going to add the rest of it onto this, but get it done tonight. So it's fresh, right? You learned it today. So let's do 1 through 6. It's section 3-4. Remember, we skipped 3-3. And it's page 132. These are all distance problems. Okay? These are just the ones for distance. There's no midpoint or slope on this. We're going to add those to it later. I tell you what, let's just make this one assignment. Is that all right? Give you more points for it, right? Yeah. So let's make this one assignment. I don't think I have that written in the lesson plans. Let me see. Give me a second, Isaac. Let me just see what I wrote in the lesson plans for this. Yeah, I wrote 1 to 22, and then the next one's 23 to 36. But let's just do 1 through 6 right now. And that'll be, we'll call this 3-4A, because I'll probably break this down into 2, maybe even 3 assignments, okay? And that's all right. Gives you 15 points instead of just 5 points, right? That'll help your grade out a little bit, as long as you do them. All right, so let's do 1 through 6. Called an audible there, and I think that'd be good. Those are all distance problems. You got 7 minutes. Look, try to get 3 of them done before class is over. Can you do that? Let's try. Try to get 3 of them done. All right, half of them. All right.